Good morning. Today we are going to discuss about the DC generators. Myself, Guna Prasad, Associate Professor in Department of EEE. These are all the contents today we are going to discuss. The first one is the classifications of the DC missions. The DC missions are classified into two types. One is the DC generator, another one is DC motor. The DC generators are again classified into two types, separately excited and self-excited. That self-excited generators are classified into three types. One is shunt, another one is series compound generator. Again, the compound generators are classified into two types, cumulative and differential generators. Similarly, DC motors also classified into two types, separately and self. Self again classified into three types. One is shunt, series, compound. The compound is classified into two types, cumulative and differential. Next, coming to the generator or motor, the function of the generator is this can convert the generator is nothing but a machine. It converts the mechanical energy into electrical energy. Motor is also machine that can convert the electrical energy into mechanical energy. The principle of this machine is according to the Faraday's laws of electromagnetic induction. These machines are works. Coming to the Faraday's laws of electromagnetic induction. The Faraday's laws of electromagnetic induction consists of two laws. The first one is whenever the conductor placed in the magnetic field, the conductor cuts the magnetic field, the EMF will be induced in it. The EMF will be induced in it. Second one is Faraday's second law. Faraday's second law states that the flux linkage rate of change of flux linkages are equal to the magnetic coil. Coming to the Lenz law is uh, used to identify the polarity induced in the current. In order to identify the polarity of induced current, here negative, in opposite direction, the current will be flows. That's the reason here the E is nothing but minus N into d pi by dt. That means here the negative sign indicate the direction of induced EMF and change in direction of magnetic field have opposite signs. Coming to the types of induced EMFs, according to Faraday's laws of electromagnetic induction, whenever the conductors are moving, the magnetic flux is stationary. At that condition, the induced EMF is dynamically induced EMF. Coming to the statically induced EMF, both the conductors and magnetic field, both are the stationary. Both the conductors and magnetic field is stationary. For that one, the statically induced EMF is induced in the transformer. The dynamically induced EMF is induced in the generator. Next, coming to the basic definitions, electrical flux. The electrical flux is nothing but the total number of electrical field lines passing a given area in a unit time defined as the electrical flux. Electromotive force. Electromotive force is nothing but the mechanical energy is converted into electrical energy, the force which is requires to motion of the electrons. That means the force is required to move the electrons from one end to another end. That force is nothing but electromotive force. Similarly, the magnetomotive force is nothing but in order to production of the flux, we required a force. That force is nothing but the magnetomotive force, MMF, magnetomotive force. This magnetomotive force measured in ampere turns. Coming to the Fleming's right-hand rule, the Fleming's right-hand rule is used to determine the direction of induced EMF in the generator. direction of induced EMF in the generator or direction of current in the generator. The thumb represents the direction of motion. The forefinger represents the field. The second finger or middle finger represents the current. The basic requirements are to produce the EMF are, first one is the magnetic field, the second one is conductor, and also relative motion. The relative motion is nothing but prime mover or IC engines. Then coming to the generator principle, the generator principle already we are discussed. Whenever the conductor cuts the magnetic field, the dynamically induced EMF is produced in the generator. That EMF causes the current to flow in the conductor. That can cause the current to flow in the conductor. That means that EMF is nothing but the electromagnetic force. Due to that force, the current is flows from one end to another end. In order to explain the working operation of the generator, here we are considering the one simple loop generator. In simple loop generator, one permanent magnet here we are taking, that is N and S. Rectangular shape, one conductor is we are taking, that rectangular shape conductor is A, B, C, D. Whenever that conductor will be cuts the magnetic flux, the EMF will be induced in it. To understand this one, at the position of 0 degrees, the conductor cuts the portion of the flux is 0 portion of the flux is cutted by the conductor. That's the reason the EMF induced in that location, A position 0 degrees, B position 90 degrees. At the time of 90 degrees, maximum portion of the EMF is induced in it, because the conductor cuts the maximum portion of the flux. At 180 degrees position, the flux cutted by the conductor is 0 portion of the flux. That's the reason EMF induced in that location 180 degrees 0. Similarly, for 270, 360 also same. At the location of 360 degrees, the induced EMF is 0. In the generator, the induced EMF is alternative induced EMF. In DC generator, the AC voltage is generated. That means alternating quantity voltage is generated in the DC. But the name of the generator is DC, na? The DC generator has to generate the DC voltage, but here AC is generated. Here we have to convert that AC into DC with the help of the commutator. That commutator can convert the alternating quantity into direct quantity. That means the commutator act as a rectifier. In this way, next coming to the construction features of the DC generators or DC machine. Generally, the DC machine has two main parts, stator and rotor. The stator consists of the pole core and pole shoes, field winding and yoke. Rotor consists of the armature and armature winding, commutator and brush. Here, coming to the constructional feature, the DC machine has two main parts. One is the stator, another one is the rotor. Again, the stator consists of the pole core, pole shoes, field winding, yoke. The rotor consists of the armature and armature winding. Again, the two parts are there. The two parts are commutator and brush. This is the construction of the DC machine. Here, pole shoe, armature winding, yoke, commutator, brush, armature, field winding. These are all the parts of the DC mission. Coming to the first part, yoke. The yoke is nothing but outermost part of the mission that can provide the protection to the entire mission. That can provide the protection to entire mission, and also it provides the mechanical support to field ports. Field ports. This yoke is made up of with the cast steel for large mission, and for the small missions, cast iron. Cast steel for the large mission, cast iron for the small missions. Next one is the pole core and pole shoe. Here, the pole core is nothing but that can give the accommodation to the field winding. That can use the accommodation to the field winding. The function of the pole shoe is it can use the mechanical support to the field winding. These two are made up of with the silicon steel. Made up of with the silicon steel. Next one is the armature. Armature always consists of the armature core. This armature core is made up of with the silicon steel. The function of the armature core is that can provide the accommodation to the armature winding. Coming to the commutator is alternating voltage is in the loop is converted into direct voltage. That means the AC voltage is converted to DC voltage with help of the commutator. That's the reason the commutator always act as the rectifier. This commutator is made up of the copper segments. This is the constructional features. Here armature core practically armature core is this one is the practical armature core, the commutator. This one is the armature stator winding. Here practically this one is the commutators and brushes. Then coming to the brush, the function of the brush is to collect the current from the armature conductor. The function of the brush is the brush collect the current from the armature conductors. The brushes are always made up of the carbon because the carbon has a more resistance that can improve the computation. A disadvantage is due to the brush, the voltage drop will be nearly occurs 1 volts. 1 volt drop will be occurred due to the brush. Next armature winding. The armature windings are always made up of with the copper. These windings are placed in the slots. These armature windings are again classified into two types, lap winding and wave winding. This is the lap winding. The lap winding is designed for the low voltage and high current. Lap wound armatures are connected in parallel. Coming to the wave winding, the missions are designed for the high voltage and low current. The wave wind armatures are connected in series. Number of parallel paths for this one is 2. For lap winding, always equal to the number of poles. Equal to the number of poles. Already we know that EMF equation is nothing but Zp pi n by 60A. In that one, pi is equal to flux per pole in Webers, Z is equal to total number of armature conductor, N is equal to number of poles. A is nothing but number of parallel poles. The number of parallel paths are 2. A equal to 2 for the wave winding, A equal to P for the lap winding. That's all. Remaining